everyone, welcome to Scitalk. Today we have amongst us Professor Evamarie Hey-Hawkins from the Leipzig University, Germany. She is a professor, she is a supervisor, she is a chemist. Almost 84 students have graduated under her guidance, and today on the occasion of International Women's Day, we are very happy to announce that we have on board Professor Evamarie Hey-Hawkins. Welcome, ma'am.
Thank you.
You have joined this Leipzig University as a full professor in 1993. So how is your journey before that, like your education-wise?
My scientific education started at Marburg University in 1976, a long time ago. And then I got my master's degree in 1982 and my PhD in 1983. So it took me only 18 months to get my PhD. And then during my PhD, my supervisor asked me if I wanted to become an academic. And I thought, this sounds great. And looking at him as a person and as a supervisor, I thought, yes, I would like to be like him. And then starting this academic career typically means that you have to go for a postdoc first. So I went to England, to Brighton, to work with Mike Lappert, organometallic chemistry. And then there I met a person from Australia, Colin Reston. And he was a main group person. And he said, wouldn't you like to come to Australia? And I thought about it, and I thought, Australia, this is a great country. I always wanted to go there. So I decided, yes, why not pick him up on the offer, because I had my own funding, I had my own grant. So I decided to go to Australia. So I went to Perth first. And then when I was at Perth, I got the offer to go to ANU, the Australian National University in Canberra. And there I joined Bruce Wild, a phosphorus chemist. And I stayed in Canberra until 1986, 87 even. And then I returned to Marburg, completed my habilitation in 1988. And then I got an offer to join the Max Planck Institute in Stuttgart. There I worked with Professor von Schneering, a solid-state chemist. So again, completely different areas of chemistry. And this lasted until 1990. And then I got a Heisenberg grant. I used that to go to Karlsruhe University. And there I started my own academic career. So this is when I had my first students, 3 of them who started to work with me. And during that time, I already taught at a university in Stuttgart. I had to go there once a week, and also in Heidelberg. And then in 1993, I was offered a position, professorship at Leipzig University. And so I moved, and 2 of my students at that time came with me. So I started out with a really small group, me, 2 PhD students, but it was a good time.
Okay, so you were the first woman professor in the department. So how did it feel being the only woman in the department as a professor?
Well, actually at that time I was not the only woman. There was another associate professor in organic chemistry, so there were 2 of us. And but she was from Eastern Germany, I came from Western Germany. And so still we were only 2 out of, at that time, I think 23. So 10% you could say. So in East Germany it's different, because women were always treated more or less equal to men, different from other countries. And so it was nothing really special. So women were just scientists. It was not the gender that somehow made you a person, but it was really just the fact that you were a scientist and what kind of science you were doing.
In your lab, the students, the funding from where it comes, do you provide the funding for the PhD, or they have to apply for a grant somewhere else?
There are many different sources, and so my students are at least funded by 4 or 5 different sources. Okay. So the first funding is from the university. So this is typically for the students being teaching in the labs, but all of my students have to teach, not only the ones funded by the university.
Okay.
Then we have the DAAD, DART, and that is typically for my international students. So a lot of them come with a DART fellowship, and I think at the moment I have 3 of DART fellows doing the PhD with me. One from Russia, another one from Macedonia, and the 3rd person is from Romania. So
you have like, you said in one of your talk that you have 1/3 of your students are not from Germany, right?
Right.
So is there any difference between students from Germany and who are not from Germany?
There is.
There is? What kind of difference?
There is. I mean, in Germany, the students, they go to school, they go to university, When they have the right grades, they can study all kinds of subjects. Chemistry, you don't need a special grade for that. And then everything is free. There's no tuition. So typically they get still funded by their parents, or if they can't, if their parents are not worthy enough, then they can get a scholarship. But they take it for granted. So this is something that you expect that happens, see? So this feeling of expectations, that this is something that you deserve and you get it. And not having to work for it. So it's there and it waits for you to take it, right? And so a lot of the foreign students who worked with me, they really got this as an opportunity, a real chance. They really saw that this was going to change their lives forever. Because having this education, they could then afterwards do many things that otherwise they couldn't have done. So for a German student, it doesn't really matter where they go. Afterwards, they will get a job. That is not a question, see? But for a lot of the students who came to work with me from outside of Germany, this really was the start for a completely different career that otherwise they could have never had.
Okay.
And so they worked differently.
They work harder than that.
They were much more serious. They were much more serious. Of course, the scientific quality.
Yeah.
If they do not understand science, then this is difficult. I can take a good student and try to turn him into a very good student or an excellent student. But there has to be a certain level of understanding of science. So that has to be there. And so this is reflected typically in grades, but I interview them. And then, of course, I learn what the understanding of science is. Then the second part, of course, is the personality. And that for me is as important as science. Because they have to be open-minded, they have to be tolerant, they have to be willing to get to know a different country, a different culture. They have to accept that not everyone is the same.
Yeah,
So this is what I said with tolerant. So if someone is very ambitious, ambition is good. But if ambition is connected with ruthlessness, so that you just follow your goals no matter what, this is certainly a person I would not want in my lab. Definitely not. So I want them to act as a team. I want them to help other people will help them. So we are a team. Yeah, and so competition is, of course, part of being a team. You compete inside the team, you compete with other teams, but you never do this in a bad way. So it's always in a nice way, just trying to be better, to become better. And so the personality is definitely very important.
Yeah. Okay, since you have said about competition, you have mentioned competition. What does recognition matter to you, like the awards and rewards?
Well, when I get an award or when I am honored with something, then of course it's always an honor for the 84 PhD students that I graduated, the master students who worked with me, my collaborators with whom I've published so many papers. And of course I always feel that it's not only honoring me, but it's honoring all the people who contributed to what we did up to now. See? And I think this is important. And so when I get an award, then of course I take the group and we celebrate, because it's also their award. It definitely is. Because without them, I on my own could probably not have achieved anything.
So, and congratulations, you received the 2013 IUPAC Women Chemistry Award. So what is the motivation behind this title? Like, why did you choose to have a title like this?
I feel that women are sometimes only tolerated.
Okay.
Politicians, of course, want equal opportunity, so they force a lot of institutions to employ women.
Okay.
So this is what I would call tolerated.
Okay.
So they're not really wanted. The industrial people, they are forced to employ more women, or other organizations are forced to employ more women. And so they do this because you force them to. They are tolerated. What I would want is that they would want women to join them, because they realize that there is potential, that women can contribute things to a company, to a university, to a team that maybe other people could not. So I would want them to be wanted. And what I'm absolutely sure of is that women are needed, because when you look at the world population, 50%, almost 50% are women. So if you would just ignore these 3.5 billion people, and just leave it to the 3.5 billion men to do all the
waste of energy, basically.
Yes, of course it would be. And of course we have different thoughts, and every individual is different. And so the creativity that we have we would miss out of that completely, and that would be a shame.
So the awards that you have received till now, so which award was the most favorite one of yours? Like that after receiving that you felt really happy?
All of them.
Yeah,
all of them. I think the one that I felt really, really happy about was when I got the honorary doctorate from the Babeș-Bolyai University in Cluj-Napoca.
Okay.
Because I started that collaboration a long time ago, and I have a very good friend, Luminița Zilagu Dumitrescu, a very strong and powerful woman. And in all the time that we collaborated, she sent students, joint PhD students, all women. And they were all amazing, all of them. And so then when they honored me with this honorary doctorate, it was like, it was just great.
Okay.
Really happy, yes.
Okay. So any role model woman scientist that you have, that you had actually when you were growing up or when you started your career? Anyone?
My mother.
Okay. Okay, let us talk about your family. So who you have in your family now?
Well, now in my family, I'm married to someone from England. So my husband, Stephen Hawkins, he's also a chemist.
Okay.
He works for a publishing company.
And we have Hawkins?
No, this is Hawkins with an S.
Okay,
This is a different one. And then 2 cats.
Yeah.
So this is us. This is our family. We live in the countryside.
Okay.
And
you don't like dogs?
I like dogs, but our cats don't.
Okay. This is not a good combination.
No,
I guess.
apparently not.
Okay. Other than that, your parents?
Are no longer alive. My mother died in 2011 already, and they got divorced. So my parents, they split up when I was 7, and so my mother was a single parent.
Okay. So you were with your mother?
And my brother.
Okay,
He is 3 years older.
Okay. So how supporting your mother was when you started your career in science? Did she say that you should do something else, or did she say that okay, you do whatever you want to do?
No, she was completely non-typical, completely. Okay. So when she grew up and you realized that this was the last century, right?
Okay.
Then she already went to high school. She came from a very poor family, but went to high school, paid it all by herself because she wanted to get a better education. And then in the end, she worked as a secretary in an office. So my brother and me, she tried to get us to do everything we wanted. So I learned how to play the piano and everything. So she really tried to encourage us to try out new things, to really explore our potential. And so when it was time to go to high school, for example, she was the one who said yes, because I knew we didn't have the money. But she said, "Don't worry about this. You go." Yeah. And so she took on another job to do this. Okay. And then I went to high school. And then when I started at university, the same thing. I mean, of course, then I had my own funding and this was different. But still, she always encouraged me, always. And she always told me, never do things because others expect you to. Do things because you want to do them. See? And so this was very good advice.
What are your hobbies? Like what do you do when you are not doing chemistry?
Oh, there is not a lot of time when I'm not doing chemistry, but
all the time you're doing only thinking about chemistry.
Most of the time, yes, really, yeah, and I really enjoy it. So when I write a paper, when the paper is submitted, when I push the submit button, it's wonderful moment, wonderful moment.
Relieved.
Or when I write a grant application and then I submit it again, so it's gone and then it's wonderful. So I enjoy this, but this is of course not a hobby that you would call a hobby. So what I like is traveling, of course. Typically I travel for work, and I like science fiction, I like music, I go to concerts.
Okay, you like science fiction?
Yes, I do.
Okay, do you watch movies?
Yes.
Have you watched Breaking Bad?
Of course. This is putting the chemist in a very, very bad position, of course, yes.
Yeah, but it is somewhat related to chemistry though. So yeah, I had to ask this question.
Yes.
Yeah, okay. Did you like it?
I liked it, even though it's not really reality, is it?
Yeah, no, of course no. But yeah, people get to know chemistry, at least see of chemistry by looking at this.
Yes.
So which place is your favorite place? Like in India, the second place?
In India? Yes. In India, it would be Goa and Bangalore.
Goa and Bangalore, everyone's favorite though. Not only yours.
Yes.
Even mine.
It's beautiful, yes.
It's beautiful. Goa especially. It's the Miami of India. You can say so. Yeah. Okay. We'll do some rapid questions. Whom do you love the most?
My husband and my cats.
If not chemistry, what would you have studied?
Veterinary medicine.
First word that comes to your mind when you think about India?
Food.
Like, for example,
Oh, I like the naan bread.
naan bread. Is it naan bread Indian?
No, it's naan. It's just naan. I like naan.
The butter naan.
Butter naan, yes.
Butter naan. Okay, okay, yeah. Okay.
And dosa is also
Are you
bread.
vegetarian or non-vegetarian?
I'm non-vegetarian.
Okay. What is that something which you don't like about research?
I would like to have a lot of money and not being forced to apply for funding. Just as much money as I could possibly need for my research.
Okay.
And
To
just
buy instruments and buy chemicals.
and pay my students, yes.
Okay. Out of 184 Nobel laureates in chemistry, only 5 are women, right? And this is happening because of many reasons. One of which is that we do not nominate women scientists. This might be one reason. So, to modify the situation, what should be done, you think?
I think women have to be more outgoing. So they have
Okay.
to talk about the great things that they are doing. Men do it all the time. Women hardly do it. And so what you are doing here with the media center, I think, is really important, because you could really use this to put women into the spotlight. You know? So to become, to make them more better known and to make the research better known, because that is what it is all about. So when you are planning a conference, for example, then you are thinking of speakers whom you could invite. So you are not going to the internet and checking things, but you are thinking of people whom you know about.
Yeah,
And
that's
these are the people that you are typically inviting. And then when you still have to fill some slots, then you start Googling. Yeah. But I think people have to be known, and they have to be known for their science and for their good research. And of course, you publish, we all publish, but this is not enough. I think, and of course, Twitter and is I'm not sure. Of course, we also tweet when we have a nice publication, sure. But I think it's really using the media to a better extent.
I checked your Twitter. It's not very active though.
No,
I guess.
it's not.
Yeah,
No, it's not.
So I think nowadays social media handles are playing a big role in popularity
Yes,
of
it does.
scientists or like politicians or actors, whatever you say. So do you think the scientists should also do more use of the social media handles? Twitter, Facebook, Instagram or YouTube, anything?
I think you have to use it nowadays,
Yeah.
because otherwise you will not be
Known. Yes.
So, and that is why I'm also on Twitter. Of course I am.
Yeah.
And when we have a nice publication, we talk about it. I'm also on Facebook, the old people's network, yeah, of course. But I think it is important, but you have to be careful, because a lot of people, they retweet things without even checking. See, they put a like to things without even knowing. And so I think this is not right. So people should be aware that even if it's on Twitter, it might necessarily not be right. Yeah?
How is your day structured like? Like what you do from morning to evening?
Yeah, it's different all day. So I have to teach, of course. So when I teach, I have my classes. Then I have my students. I meet with my students. Typically, I have some type of refereeing to do. I don't do this during the day. I don't have time. I do this in the evenings and weekends. So during the day, it's really committee meetings, talking to people, trying to solve problems.
Do you like to cook?
No,
No?
no.
Okay.
I like to eat. I don't like to cook. My husband cooks.
Ah, that's really great.
It is, isn't it?
Okay. So after you have become a full professor, what are the challenges do you had to face?
Acceptance, because at that time I was still fairly young. So I was appointed professor at the age of 36. And I still looked very young, so a lot of students thought I was one of them.
You look really
And,
young now also.
Oh, well. So, and this was definitely a challenge, because if you want someone to respect you, of course, when you're an older people, this comes naturally. When you're a young person, then you have to work for it. And so when you have a group and you tell your co-workers, please do this in a kindly way, you expect them to do it. But then, of course, they have to respect you to really do this. And so this is something you have to work for. It doesn't come by itself, but this kind of respect from your group, from your colleagues, that is something that you need to get with time. The challenges, in the beginning, when I said something in a committee meeting, people would say yes, yes, and would ignore it completely. So they would just talk about something else, and then with time they realized that my inputs were valuable. See? And again, slowly but surely they were listening to me. But it was also a slow process. And in the beginning it was really frustrating because you felt that this is important what you are saying and no one was listening really. So I think when you become a professor, when you are a bit older, then this is easier. I think this is a problem because I was really young at that time and a woman. But then I don't think that this is only a problem for women. I think this is also true for young male professors because the experienced ones will always think, oh yes, we know. They don't. And so a good advice would be to listen to the young people because they typically have good ideas. They have new ideas. Older people, they have experience, and that is also important because from experience you learn. But experience sometimes prevents you from doing things in a specific way because you already know, no, it's not going to work. And a young person who does not have this experience will be willing to try and maybe even succeed. See? And so this was a bit frustrating at the time, but now that I realize it, when I'm heading a committee, I try to behave differently.
Okay. That was my second question. That do you listen to the young faculties now? Okay.
Yes.
So you do.
Yes.
Okay. So is it easier to get grants after you have become known or experienced rather than when you were young?
Easier? I wouldn't say so. I mean, when you are young, there are a lot of grants out there, and if your track record is good, you can get them.
Okay.
And so this is fairly easy, but you have to be really good. Then when you're a professor, you're expected to fulfill your expectations, the expectations of the people who employed you. And then, of course, when you write a grant, you can't just put your ideas there, but you would have to have results. And so you would have to convince people that what you're proposing is feasible, that is manageable, that you can do it. And so for a young person, of course, who is just starting, people would have to trust that whatever you are saying, this is going to be possible, and you can do it. But for a more experienced person, people would always know that I have the infrastructure, that I already have publications and so on. And so for that, I think my applications would have to be better. So with already more background to it, that would be expected.
Why is it very important in science to have result always? It might happen that sometime you have tried something and not get result, right? But to publish, like when you get a grant, you have to publish. But to publish, you have to have results.
Yes.
But it might happen sometimes that you may not get results. So this is the question I have in mind all the time. Like in science, it looks like that you have to have results.
Of course.
Which is like, it might happen, you may not have positive results sometimes, no?
That is a very good question. And of course, most of the time, you do not have results. So you start an experiment, you design it, you do the reaction, and it fails. And this is part of the training. I mean, a lot of times you do something and it fails. But just to be persistent and to keep with a new idea, keep following, pursuing this goal, sooner or later you will succeed. I mean, if it's achievable, then students or we as scientists, we should get there, see? But you will fail a lot on the way. And this is also part of the training, because if you have an idea and it doesn't work, then to understand why it didn't work is really important, because it might help you design the next experiment. And so if a student just keeps repeating the same experiment that failed all the time, then of course, this is right, this will never succeed. But you learn from failures. And so it's only a matter of time. So the result will be there sooner or later, but sometimes it can take a long time, and it can take longer than the funding period of a project. And then typically what you do is you have a backup plan, because you can't really just go with no results. That is not possible. So you always have a backup plan, something that is going to work. And the same, of course, for the students. I mean, the students, they have to graduate. You can't really let them work and work and work for ages and not having any results that they could graduate with, right? And so then you just sooner or later fall back to the backup plan and do something that will definitely work. It's not what you really wanted to do, but then you leave this for later. But you never really give up, right? And so I think this is also something, never giving up, at least not when you feel there is a chance you can achieve this. Stopping something when you really think it's useless, then that also is a decision that you need to take. But when you still feel it can be done. It can be done. Maybe not with this student, but maybe with another student.
Okay.
Then you
So-
keep doing it.
So what are your future plans?
So what we are doing now at the moment is in catalysis really the CO2. So this is what we've just started together with a group in Israel. So we got a grant for that, and so now we are looking for students to do this. So this is catalysis is definitely one of the areas, and another part of catalysis is a big European Union project on catalysis, where we are looking for 15 PhD students and are already advertised here that we are looking for students, and this is also in catalysis. So I think this is very important because catalysis helps us to make compounds in a greener way, so more sustainable. And the other area is our medicinal, bio-inorganic medicinal area. That is also very important in many ways. So making new drugs, even though it takes a long time to bring them to the market, I mean, just maybe starting something that maybe other groups are also picking up might help develop new drugs that might really be able to treat cancer one day. So that is definitely one of the things that I want to do. And in material science, of course, we are typically collaborating because we mainly make the molecules, and of course we're also collaborating with IISER. And so again, this is a very good collaboration where we can make, for example, together with Professor Bhumi Shankar, molecules that can select out of a mixture of molecules just one. And of course, again, this is very, very important because in some cases, separation, because in some cases, you find it very, very difficult to separate molecules. We always have our ways, but sometimes these don't work. And so his way of designing containers that could really just grab one molecule out of a mixture of many is great.
So what kind of catalytic reactions you have explored till now?
Several. So we have equipment to do hydrogenation and hydroformylation. And so this is a very big setup. We have 16 autoclaves, and so we can do 16 reactions simultaneously with modifying the temperature, solvent, even the catalyst, even the substrate. But hydrogen and carbon monoxide are always included at the same time. So that is one of the setups that we can use. And of course, all the coupling reactions. So palladium, CC coupling, all of that we can do. Yeah,
but the CC coupling reaction is well explored. So what you are doing new like in that area?
Yeah, well, I mean, CC coupling is well explored, but there are so many compounds out there where you could really use new coupling reactions that this could become important. Yeah.
Do you explore other like CN coupling reaction or CUO coupling reactions other than CC coupling reactions?
What we do is we study the hydroformylation, so formation of, no, sorry, not the hydroformylation, but the hydrogenation of carbon dioxide. So, you know, carbon dioxide is one of the problematic compounds. And so we are trying to prepare catalysts that really activate hydrogen and make formic acid out of CO2. So that is another type of chemistry.
So that we can, you know, solve the problem of extra carbon dioxide we are getting in the world, right?
Exactly.
What metals you work on mostly for making the complexes?
Oh, now in catalysis, we are typically working with the noble metals.
Okay.
Our collaborators also use other metals. So, noble metals. That is us. It's noble metals.
Okay.
Yes.
So you have collaboration in Pune University as well. So can you just tell us how it started and when it started?
Started in 2008. In 2007, Germany had a so-called Excellence Initiative, and we were lucky enough to get a graduate school of excellence that was called Building with Molecules and Nano-Objects, built MONA. So we still have that today, so it was continued even after the funding from the Excellence Initiative stopped. And so then during that time, after we got the funding, we went all around the world to advertise, of course, for the schemes. And so the DAD, the DART, DFG, Humboldt Foundation, many institutions, they joined forces and organized trips, and one was to India. And so in India, we went to several places, and one of them was Pune. And so I met people at NCL, I met people at Pune University, and I saw the Mendeleev building here at IISER, where they just started to equip the lab. So this was really interesting. And this was when I got to know Avinash Kumba, so I've known him a long time, and also Veda Puhanik from the NCL, he's now retired. And then when I was back home, I got an application from a student from Pune University, Suvik Pandai, and he came to work with me as a PhD student in 2009. And so this was how it all started, more or less.
Okay. Thank you, Professor Eva-Marie. Thank you for being here today. We are glad that on the occasion of International Women's Day, we have you here. And thank you for joining us today.
Thank you for having me.